Welcome to our discussion on evaluating variable expressions. We only have one objective today, and that is to simply evaluate a variable expression, which is a fancy way of saying plug some numbers in and see what you get. It's basically just an introduction into remembering that letters are just numbers in disguise. And when we're dealing with letters, when we're doing all this algebra, we're really just moving numbers around. So you can't do anything with letters that you couldn't do with a number. When you see a letter, you need to think of that as just a number in disguise. It's like a present. It's a box that's been wrapped up, and inside that box, you open it up, you go, oh, it's a 3. Yay, it's a crappy gift. But that's what it is, right? So when you're moving around these variables, you're just moving around numbers. Okay, when you're dealing with negatives, don't forget that you can always think of subtraction as just addition of a negative number, if that helps you to not make mistakes. Also, just so we're all speaking the same language, when you hear the word terms, right? Term or terms. A term is any clump of things that is separated by plus or minus. So you can see this first term is 3x squared. It's technically made up of 3 pieces. It's made up of a 3 and 2 x's, right? But those 2 x's are multiplied together just like they're multiplied by the 3. But when you multiply 2 of the same thing, you just raise it to a power, right? So it might look like only 2 objects, but it's really 3. Whereas this is 2 objects, right? 5 times y, here's 3 objects. 2 times x times y, here's 1, just an x. And then here's 1 as well, just a 7. Now we call that a constant term because it's made up of just a number, and we call these variable terms because they have variables in them. But the more important thing to understand is they're all terms, and you move them around as a clump, right? You move this entire piece, this entire 2xy gets moved around when you're working with it because those things are multiplied together, and when they're multiplied together, they're cemented together, right? 3 times 5 becomes 15. That's a whole new thing. And when you have 3 times x, that's the same thing. We just don't know what x is yet, and when it takes on that value of 5, it becomes 15. But when it takes on the value of 2, it becomes 6. But the idea is they're still cemented together. Okay, numerical coefficients, again, fancy words for just the numbers in the terms, right? So this term has a numerical coefficient of 3, this one of 2, and so on and so forth. We don't call this a numerical coefficient because it's just a constant. Right? In order to be a numerical coefficient, it has to be cemented to some variables. Don't forget that when you see a variable all by itself, so you'll remember in the previous slide, this was just negative x. Anytime you have a variable all by itself, whether it's negative or positive, there's always a little invisible 1 in front of that. So that negative x is technically negative 1x. And if it was plus x, it would technically be plus 1x. So just remember that there are always those little invisible ones in front of those, constants that are all by themselves, or sorry, those variables that are all by themselves. Okay, why do we deal with all this junk? Well, because most things in the real world can be modeled with variable expressions. For instance, in a physics lab, you might discover that the weight of a pound, right? The weight, if there's a weight that weighs exactly 1 pound, will stretch a spring by 1/2 inch. 2 pounds will stretch the string by 1 inch. And so by experimenting that, you can discover that the distance the spring is stretched is always found by multiplying the weight by 1/2. So if we put a 10-pound weight on that spring, how far is it going to stretch? You go, okay, well, 10 times 1/2 is 5. It's going to go by 5 inches, right? So that we could set up as a variable expression as 1/2 times the weight is going to equal, you can think of the length that the spring stretches, right? That kind of thing. So that's a simple version of a variable expression that we can use to then solve things like, if you put 3 pounds on it, how far does it stretch? And if you put 12 pounds on it, how far does it stretch? And so on and so forth. So right now we're just talking about setting up these basic expressions and being able to plug numbers in to realize that the letters are just numbers in disguise. Then we're going to take it a step further in our next videos and start working with these expressions and moving them around and solving them. But for now, simply if we want to evaluate ab minus b squared when a equals 2 and b equals -3, you plug those numbers in for those variables. You put the 2 in for a, the -3 for b. Remember your order of operations. First, you have to square this, and -3 squared is +9. 2 times -3 is -6. And you think, well, then why is this -9 if this becomes 9? Well, because there's the minus sign out here. So we're subtracting that thing that's been squared. We square it to get a +9, but then we subtract it, and it ends up kind of becoming negative in the end anyhow, and our answer is -15. All right, one last example. X squared minus 3xy, we plug in x equals 3, y equals -4. Again, remember your order of operations. You square the 3, that gives you a 9. Then you do the multiplication, 3 times -4, right? And that's 3 times 3 is 9. 9 times -4 is -36. So you get 9 minus the -36. When you subtract a negative, it becomes adding a positive, and you get a final answer of 45. Okay, so that just should be a quick, easy introduction into working with these variable expressions.